What's up, everyone? We're gonna change this to C++. So I did the LeetCode video for Python. I'm gonna do this for C++ for this problem, LeetCode 105, right? We're given a preorder and an inorder list, and we have to construct a binary tree. Okay, preorder means we handle the root first, so we do 3, 9, 20, 15, 7, right? Inorder means we go left, root, right. Okay, so we're gonna go 9, 3. We don't handle this 20 just yet because we have something on the left, so then we go 15, then 20, and then 7, okay? So given these two inputs, we have to basically construct this tree given these inputs, okay? So really the idea behind how we're going to do this is we're going to traverse preorder, right? And pluck a root, and when we pluck that root, we're going to basically find it in inorder. Oh, like pluck this 3. We're going to find the 3 here, okay? And we'll notice everything to the left belongs in the left subtree, everything to the right belongs in the right subtree, okay? So we're basically going to use that to our that knowledge to our advantage and recursively build out a binary tree, okay? Now, in terms of, so when we find a root, like we pluck this 3, to find it here, we don't want to do a linear scan every time, so we're actually going to use a hash map or fast lookup, okay? So we're going to do that. We're gonna do that. So we're gonna say unordered map int. We're just gonna call it mapping. And we're not gonna use a for loop. We're just gonna use a variable called current to traverse preorder, right? So it's gonna be 0 because we're gonna start at the 0th index, right? So first of all, let's populate our hash map, right? The value for the hash map will just be the index, and the key will just be the actual value in order. So for example, 9 would be mapped to 0, 3 to 1, etc., right? And again, this is just for fast lookups so that we don't have to do a linear scan every time, because then our solution would actually be suboptimal, because, well, if we're doing a linear scan every time, right, that's not very efficient. And in an interview, that would probably cost you your interview if you had to compete with someone who used a hash map. So you don't want that to happen to you. So yeah, we're just doing fast lookups because lookups are O of 1 in hash maps, right? So we're gonna remember make a function and we'll recursively call it. Okay, so we have to write this function still, but this is just some boilerplate, which we'll touch back on in a bit. So don't worry about it too much. Private. Okay. So let's create our function. Okay. So basically we're going to first of all have a reference to preorder because that's what's important. Because remember when we find the root value in inorder, well, we need to call preorder first. We're going to use preorder to basically I'll explain this. We're going to use preorder to find the root, so that's why we need a reference to it. And then when we call the hash map, we'll know where it is in inorder, so we can basically handle our window, given that we know where the root is in order. Okay, we're gonna have values left and right. Right, this is basically our window of what we're looking at in the tree, right? I'll explain this more, like I said, so don't be too confused. Don't go crazy just yet. So if left is right at any point, return null pointer, right? We need this because, like, obviously if we're at this 9 and there's no child nodes, we need something to break out. You know, we don't want to be stuck in an infinite loop or anything. So remember, current, the variable current, which is initially 0 right at the top under public, that's really just so we can use that variable to just traverse preorder. Rather than doing it in a for loop, we're just going to use a variable. So we're going to say preorder current, right? Initially it's 0. We're going to get the root value 3. Okay. Now let's find where 3 is in order. Okay. We're going to say int middle mapping. mapping. I want to say root val. Okay. And it's the middle, obviously, because everything to it's in the middle of the binary tree currently, right? Everything to the left is in the left subtree, everything to the right is in the right subtree, right? So let's actually create that node because we need to actually build a binary tree for our output, right? So we're gonna say new tree node. We're gonna say root val. Okay. Now, in terms of how we handle the left side, we're gonna say recurse in order, preorder left middle -1. And for the right side, because when we go to the left subtree, only the right window is moving, right? Because the left window is not going to move because the left side of the window is not going to move because, well, that should be in the left subtree anyways. Reorder middle +1 and then right. Okay. Let me see. Boom, 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 boom. Seeing if I have an error. I don't believe. I know we're using preorder really only in this function, but the reason I call it recurse in order is because we're basically finding where the middle is using the in order array, right? That's the point of the hash map. Okay. Don't get confused by that. Oops, I don't have an equal sign. But you can name it, or you can name it parse, whatever. Just name it recursion. I don't know. If you want to change the name, it's up to you. It doesn't really matter to me. Oh, sorry. We also want to make sure we increment current after we use it. That would be very useful. That would be very useful, actually. So yeah. Now when we call this function for the first time, we're passing it the 0th index and the end of this, because this is the window initially, right? Makes sense? We're looking at this entire thing at first to construct our tree. Yeah, I think the solution to this problem is a little funky. Honestly, I think it's a very weird problem because you're given an in-order list and a pre-order list, and you have to create a binary tree. But I mean, this is just a solution. I don't know what you want me to tell you. I hope I explained it somewhat okay. I mean, I think why we're using a hash map makes sense, right? Fast lookup. This our window initially has to be this whole thing. Current is really just to traverse through pre-order, right? The index is 0 initially. I don't and this part here, the recursion, really, we're basically finding the root value, right? So let's find this 3. We're using the hash map to find out where the 3 is. Okay, this is the middle. Now let's recursively, so let's add this to the tree because this is the root, this 3, right? And then handle everything to the left and everything to the right subtrees recursively, and by basically properly sizing the window, given that we know what belongs to the left and what belongs to the right. And again, we have a base case to break out because, well, we can have null nodes, right? We can. I said can. I'm not sure if I might pick that up. We can have null nodes, right? Like here. So yeah, I think that's it. I hope this helped. I hope I explained it okay. I mean, it's just a very weird problem. Like, I don't know what to say, but I think the solution is clean. There's probably some solutions out there that are, I don't know, easier to understand maybe, but I found this one to be the simplest. So yeah, I hope this helped, and I'll see you in the next one. Peace out.